Good morning, everyone. Today we shall see Unit 1 Control System Modeling in our subject Control System Analysis and Design. First, we shall see about systems and control system in a detailed manner with an example for more understanding. Okay. So, first of all, what do you mean by system? So, as we have seen in yesterday's class, system is a physical set of components that takes a signal as input and produces a signal as output. See here the block diagram given. Here we are having a system. In a system, we are going to give an input and what comes out of the system, that is the output. Okay. That is what a system is. We are going to give some input to the system and we are going to obtain a output from the system. We can also say a system is an arrangement of different physical components connected in a manner to form an entire unit to attain a certain objective. That is, we design a system to meet a certain objective. Okay. For a particular purpose only, we are going to design a system. For example, if I am considering electric bread toaster. So what is the purpose of electric bread toaster? To toast the bread. Okay. That is, I will turn on the AC supply. I will switch on the electric bread toaster. And what the output I will get? The toasted bread will be the output from the electric bread toaster. Okay. Likewise, we are having some more example of a system, that is washing machine to wash the clothes and electric water heater to heat the water. Likewise, each and every system has a input and will be getting a output from the system to meet a certain objective. Okay, each and every system has a objective. Okay, this is what a system means. Then here we are going to see about control system. So I am taking the word control. So what does the word control mean? Control means to regulate or command or direct. Here we are relating the term control to the system. So what do you mean by a control system? So here we are going to regulate a system or direct a system or command a system. For what purpose? To get a desired objective. Okay. This was the term control in control system mean. So system plus control leads to control system. Okay. So that's what we are saying. A control system. We can say a control system as an arrangement of different physical elements in a manner to regulate, to direct or command itself to achieve a certain objective. Okay. So what do you mean by control system? In a control system, we'll be having arrangement of different physical elements. For example, I am taking a electric heater. If you take a electric heater means we'll be having a heating element, which is the major component of an electric water heater, and associated with that we'll be having some insulation and some other components. There's a water inlet, water outlet, and the container inside the electric water heater. So all these are different physical elements available within this electric water heater. Here I have taken the electric water heater as an example of control system to explain this definition for you. Okay. So if you take a control system, there will be a different physical elements like we see in the electric water heater. So all those are connected in such a manner to regulate or direct or command itself to a certain objective. So in electric water heater, what is the objective? To heat the water to a particular temperature. Okay. So for that, what we are going to do? The heating element will be heating the water. That is, we will be switching on the AC supply. Okay, that is, we will be turning on the switch for the electric water heater, and the heating process will be taking place inside the electric water heater. That is, it will be directing the system based upon the input given to meet a certain objective. So here the electric water heater is given an input as AC supply. We are turning on the switch. So AC supply is given, and in what manner we are directing? To heat the electric water heater to a particular temperature level. To meet that objective, we are directing the electric water heater. Okay, so this is what a control system. So that's why I'm saying control system is arrangement of different physical elements connected in a manner to regulate, direct or command itself to achieve a certain objective. Certain objective means each and every system has its own purpose. To meet that purpose of the system, the input will be regulated to produce the output. Okay, so for a control system, also we'll be giving an input to obtain a output to meet the certain objective. Okay, so this is what a control system is. For better understanding, you will see the difference between a system and control system, because in both the system and control system we said we are going to give a input and we are going to get a output. So in what manner the system and the control system varies, we will see that. Okay, see in this slide we are having a block diagram in the left side under difference between system and control system section. See here there is a system and an input signal is given to the system and a proper output signal is obtained from the system. Here, what do you mean by proper output signal? So the proper output signal may be desired one or not desired one to the user. Okay, see I will say what do you mean by desired or what do you mean by non-desired with an example in the upcoming slide. Okay, then next, the system means we'll be giving an input and we'll be getting a proper output. That proper output may be desired or may not be desired. Okay, so if you see a control system, in a control system also what we are going to give an input, but the obtaining result from the control system will be a desired one. Okay, so the output from the control system will be a desired one. So for better understanding the difference between system and control system, let's see with an example. See here, for explaining this I have taken an example of fan. So fan is a system. So for a fan we are giving an input, that is a AC supply. We'll be turning on a switch to run a fan. That is we are giving a AC supply of 230 volt 50 hertz to the fan. And what is the output obtained from the fan? That is the airflow. When we switching on the fan, we'll be getting airflow. So that is the output we are getting from a fan. Okay. So here this fan is a system. We'll see whether it is a system or a control system. We'll see that. Okay. So in a fan, we are giving an input as while turning on the switch of the fan, AC supply 230 volt to 50 hertz is given and the output is airflow. Okay. See here in this slide, you all can see here we are having a fan without blades. Okay. If we are having like this, a fan without blade means it can't be a system. Why I am saying so means a fan without a blade can't be a system. I am saying it because what is the output of a fan? Airflow. The fan doesn't have any blades means it can't produce a airflow at all. So I am saying this type of fan is not at all a system. A fan without a blade can't be a system because it doesn't produce a desired or proper output at all. What is a desired or what is a proper output we want from the fan as a system is airflow. But without the blades, there is no possibility of getting a airflow from the fan. Okay, even if we give the input, there is switching on the power supply, there is AC supply 230 volt or 50 hertz, we won't get the output, there is a proper or desired output from the fan because there is no blades in it. Okay, so here this type of fan is not at all a system, so we can't say it as a system if a fan doesn't have a blade. Okay, next I am saying a fan can be a system. How a fan can be a system, I will illustrate. So here in this slide I am showing a fan which has 3 blades. So here also I am going to give the same input, that is switching on the fan by giving a AC supply, is 230 volt or 50 hertz supply is given to the fan, and what is the output obtained from the fan is airflow. Okay, this airflow is a proper output because what will expect from the fan, there is the objective of a fan as a system is to generate airflow. So this airflow will be obtained from the fan. Okay, this is a proper output. After I am saying desired output, will be clear with this term proper output. Okay, so fan can be a system if it has a blade to produce a proper output, that is airflow. Okay, the next condition I am saying a fan can be a control system. So when a fan becomes a control system, when it contains some control element. So here this control element is nothing but your regulator. Okay, the fan with the regulator. So what is the purpose of regulator? Regulator is used to select the speed at which the fan blades are rotating. Okay, so when we can say a fan as a control system, if a fan comes with a regulator, we can say a fan as a control system. How I am saying, I will explain. So here also I am switching on the fan by giving a 230 volt power supply. So after turning on the fan will run and it will produce a desired airflow. There is a control, airflow will be generated and that airflow may be controlled. If you want more airflow from the fan, you can increase the speed of the fan by using the regulator. So here regulator act as a control element. So using the regulator, we are increasing the rotation of blades in the fan, thus generating a controlled airflow. If you want a airflow at a high speed, you can increase the speed of the rotating blades in the fan using regulator. If you want a low speed airflow, okay, then you can decrease the speed of the rotating blades in the fan using the regulator. So here when a fan becomes a control system, if it comes with a control element, regulator. Okay, so I hope now you can understand what do you mean by a control system. It is a control system means it has some controlling mechanism. Okay, that is what a control system is. So here a fan becomes a control system and it includes a controlling element, regulator. So when we can say a fan as a system, if it doesn't has a regulator, only we are having a fan, then when we turn on the fan, a simple airflow will be generated. That is a proper output. We are getting an output from the system, that to a proper output, but it is not controlled or it can't be controlled. So we are saying it as a system. So when a fan becomes a control system, when it comes with a regulator. If it comes with the regulator, we can control the airflow generated by the fan. So thus it becomes a desired output. That is, the user can get the desired output from the system if it is a control system. Okay, I hope now you will be clear about proper output and desired output. Okay, desired output means it can be controlled. The output can be controlled. Okay. Now we have seen what do you mean by system and what do you mean by control system with an example. I hope it will be clear to you all. Next we will see the classification of control system. So till now we have seen what do you mean by system and what do you mean by control system. Then example how we can differentiate a system and a control system. Next we are going to see about the classification of control system. We can classify the control system as a open loop control system and closed loop control system. We are having two types, open loop control system and closed loop control system. We will see each one by one. First we will see about open loop control system. So what do you mean by open loop control system? Means it is a system in which the control action is totally independent of output of the system. Okay. So in open loop system there is no control of the output of the system. That is here the control system does not automatically correct the variation in its output. Okay, that's what we are saying in open loop system. So in open loop system there is no mechanism for automatically correcting the variation in the output. When does the variation in the output may occur? Due to the system usage. Not proper usage of the system or any noise arise in the system, there may be a variation in the output. But that variation in the output is not automatically corrected means we can say it is a open loop control system. So what do you mean by open loop control system? It is a system in which the variation in the output is not automatically corrected. Okay. See here below in this slide we are having the block diagram of open loop control system. Here in the open loop control system the first section is controller. Okay. To the controller section we are giving a input signal. Here some reference input is given. Okay. Because I am taking it as a general block diagram of an open loop control system. So a reference input signal is given to the controller, and after the controller will be having a process or plant we can say. Okay. So what is the purpose of controller in a control system? Means this controller regulates the input given to the system. It controls the input given to the system. That is the purpose of controller. And what is the purpose of process? This process is also known as plant. What is the purpose of process means? It is used for performing the desired function of the system. You said we have seen that the purpose of fan is to generate airflow. So that operation generating airflow by the fan is done by the process element. The controller element will control the input signal given to the open loop control system. Okay. This open loop control system has two sections. One is controller, another one is processor. The reference input or the input signal is given to the controller and the controlled output is obtained from the process. Okay. Both the controller and process are connected in series in open loop control system. Okay. We will see with an example for an open loop control system. Here I have taken an example of electric hand dryer. So what is the purpose of electric hand dryer? So the purpose of electric hand dryer is to dry your hand when you keep under the electric hand dryer. Okay, here this electric hand dryer, what it will do means it will generate hot air as long as we keep a hand under the electric hand dryer machine, irrespective of how much our hand is dried. Okay, as shown in this figure, we will be keeping our hand under the electric hand dryer and it will be drying our hand, but irrespective of how much our hand is dried, the electric hand dryer will generate hot air. Okay, that is, even when our hand becomes dry, the electric hand dryer will generate hot air continuously. That is, if I am saying if a small kid is using electric hand dryer, means the kid may keep his hand under the electric hand dryer for a long time, and he or she will be drying the hand. But irrespective of knowing that the hand is dried, the kid may use the electric hand dryer for a long time, because the kid doesn't know whether the hand is dried or not, because we can't say the kid will be playful and to enjoy the hot air they may be keeping the hand under the electric hand dryer for a long time, so we can't say that. So in this case, from this electric hand dryer open loop control system, we are getting a controlled output. What is the control output? Hot air. The hot air is coming, but this hot air is not automatically corrected depending upon the variation in its output. That is, even when the hand is dried, the hot air is coming out from the electric hand dryer. That is, the output is not automatically corrected. When the hand is dried, the electric hand dryer may turn off. Like that, it may sense whether the hand is dried or not. And if it sense the hand is dried or not, and then it automatically turn off the electric hand dryer, means it is a closed loop control system. But here in this open loop control system, electric hand dryer. Okay. Next we will see the example, automatic washing machine. So this automatic washing machine is also an example of open loop control system, because this automatic washing machine runs according to the preset time, irrespective of checking whether the washing is completed or not. Okay, what this automatic washing machine will do? It will run according to the preset time only. The clothes may have been washed before the preset time or after the preset time, but it is not known to the machine. So we are saying it as open loop control system, because here the correction or the variation in the output is not automatically corrected. What is the variation? As the cloth may dry before the preset time. Okay, that variation is not automatically corrected by this control system. So I am saying this automatic washing machine is an example for open loop control system. Okay. Next we will see the advantages and disadvantages of open loop control system. So in our open loop control system, we had two sections. There is a controller and process. So it is simple to construct and it is easy to design also. So we can say it is cost effective, that is economical. It is also easy to maintain, because we are having only two sections and the system is also not complex. It is simple, so it is easy to maintain, and so the stability can also be achieved. Because the system is simple, so we can achieve the stability easily in open loop control system. These are the advantages of open loop control system. Next, what are the disadvantages of open loop control system? We see means the results or the output are not accurate. Okay, the output or the result obtained from the open loop control system are not accurate. It is inaccurate. Why we are saying means, see in the example we have seen in the electric hand dryer and automatic washing machine, the output obtained is not automatically corrected depending upon the variation in the surrounding environment or in the input or in the system usage. So we can say that the output obtained from this open loop control system is inaccurate. Next we can say it is unreliable. Since the output is inaccurate, the system is also unreliable. Why we are saying this? Because any change in the output cannot be corrected automatically. So these are the disadvantages of open loop control system. Next we will see closed loop control system. So what do you mean by closed loop control system? It is a system in which control action is somehow dependent on the output. Okay, in closed loop system, the output has an effect upon the input in order to maintain the desired output value. Okay, here in this closed loop system, the control action is dependent upon the output. Okay, see here below the block diagram of closed loop control system is given. Here we are having various sections. That is, first we are having reference transducer. So what do you mean by a transducer? Means it is a device for converting physical quantity to electrical quantity, or it is a device for converting electrical quantity to physical quantity. We can say in both the terms. Okay. To explain this block diagram of closed loop control system in a clear manner, I am considering an example of automatic electric iron. Okay, I am taking this example, automatic electric iron. So here I am considering this automatic electric iron. What is the purpose of it? To iron the cloths placed below the electric iron. Okay, that is the purpose of it. Here in this electric iron, how this transducer will be used? If you see means, for this electric iron, will be turning on the power supply, AC supply, 230 volt or 50 hertz. So while doing so, we are converting the electrical quantity into physical quantity. What is the physical quantity we obtained from the electric iron? That is heating the cloth placed beneath the electric iron. Okay, the heating is a physical quantity. So using this transducer, we are converting the AC supply given to the electric iron to the physical quantity, heating the cloths placed beneath the electric iron. Okay. So here for this transducer, we will be giving the command input. Here what is the input in case of electric iron, automatic electric iron, 230 volt AC. Okay, and there we are having some round symbol. I will explain it later. So after that we are having a section controller. So what is the purpose of controller? It will control or regulate the amount of input given to the control system. And next we are having plant. This plant is otherwise known as process. What is the task carried out by this plant? Heating the cloths in case of electric iron. Okay, so that will be happening here. Here we said it is a closed loop control system. So based upon the feedback, so I am saying it as a electric iron. So it is an automatic electric iron. So for example, if I kept the automatic electric iron in silk mode, I am going to iron a silk cloth. So for a silk cloth, a particular amount of heat only should be generated by the electric iron, and it should be given to the cloth placed underneath the electric iron. Okay, so the amount of heat given to the cloth should be monitored. So for that we will be having some sensing element. That sensing element will be sensing the heat given to the silk cloth. So initially, while turning on the electric iron, will be having less amount of heat to the cloth. Over some point of time, the cloth may get overheated. So to regulate the amount of heat supplied to that cloth from the electric heat iron, will be having a feedback transducer. See, from the output, from the control output generated from the plant, we are having a feedback transducer. So this feedback transducer, what it will do? It will sense the amount of heat supplied to the cloth in case of electric iron. So the heat supplied will be sensed. If the heat is very less, means the plant will supply more heat to the silk cloth. If the heat is already the cloth is overheated, means the plant will supply less amount of heat to the cloth. So that feedback is given by the feedback transducer, whether the cloth is overheated or it is heated in a less amount. So to monitor or to sense that, we are having this feedback transducer. So from the output only, from the control output only, we are going to monitor that. What is the control output here? The generated heat. So from that generated heat and the cloth only, we are going to monitor the amount of heat. So from that control output, this feedback transducer is given. Okay, this control output is given to the feedback transducer, and it will check with the input coming from the electric iron, that is the AC supply. Okay, as long as the AC supply is there, the electric iron will generate the heat. If the electric iron supplies more heat, that is the cloth is overheated, means the electric iron, here we had considered automatic electric iron, so it may get turned off. So depending upon the feedback, we'll be having a feedback signal and will be generating a error signal. So this error signal is nothing but the command input minus or plus the reference input. That is based upon the input given and based upon the feedback. That is how much the cloth is heated. So based upon it, we are controlling the input. Okay. The cloth is overheated, means the automatic electric iron will be turned off, and thus the heating process will be stopped. Okay. So if you see the block diagram of this closed loop control system, means we are having a command input that is given to the reference transducer, and it is given to the controller and plant section. This controller and plant section is the two section which was available in open loop control system. In open loop control system, we had only these two sections. Here in closed loop control system, we are having a reference transducer and the round signal, the round symbol, that is known as a summing point in our control system. We'll see it later. Okay, and that summing point, and then we are having a feedback transducer. So we are having several components in this closed loop control system, thus making the system complex to look. But here we are having a desired output in a controlled manner. That is our expected output. That is, the output is accurate. In an open loop control system, we may have a inaccurate output due to some variation, that is due to some noise and all. But here in closed loop control system, we'll be obtaining a accurate input. Sorry, accurate output. That is, I said, with the help of this electric iron, automatic electric iron, that is, the cloth will be heated in a appropriate proportion. Okay, in a correct manner, in a perfect manner, the cloth will be heated. The cloth won't be overheated or it won't be less heated. Okay, thus the control output is given with the feedback link. So in a closed loop control system, we are having a feedback. This feedback is provided to maintain a automatic correction in the output depending upon the variation. That is depending upon some noise or depending upon the variation in input. Okay. So this is a closed loop system. So for this closed loop system, we have seen the example of automatic electric iron, and also we are seeing the another example, that is air conditioner. So what is the purpose of air conditioner? It is used to maintain the room temperature. Okay. Here we will be using a AC remote and you will be keeping some temperature. We will be setting a room temperature. But before turning on the AC, there will be some room temperature. But while turning on the AC, the set temperature level, say 20, may be set to the room. So if the temperature of the room before turning on the AC is high, means the amount of air, there is a compressor will run faster and it will reduce the room temperature to 20. Okay. If the room temperature is 15 degrees Celsius, means if we are keeping it to 20 degrees Celsius, means it will increase and it will keeping it to 20 degree. Okay. Likewise, in air conditioner also there is automatic correction in the output depending upon the variation. Okay. So these two are the examples of closed loop control system. So in closed loop control system, there is a control action on the input. That is what do you mean by closed loop system? A system in which the control action is somehow dependent on the output. How we are making it dependent on the output? By using a feedback link. Okay. So for that we have seen two examples, automatic, electric iron and air conditioner. Next we will see the advantages of closed loop control system. So this closed loop control system are more accurate. Okay. Because it corrects the variation in output, we are having more accurate even in the presence of non-linearity. Non-linearity means if there is some noise or even there is no proper usage of the system, we may get the more accurate result. So here the highly accurate as any error arising is corrected due to the presence of feedback signal. So here the advantage of closed loop system is the feedback signal. Because of this feedback signal only we are able to correct any error in the output signal. And next it facilitates automation. This closed loop system only permits automation mechanism. And this closed loop system is less affected by noise. So these are the advantages of closed loop system. Next if we see the disadvantage of closed loop system. Closed loop system are generally costlier because we are having several sections in closed loop system. That is for a feedback mechanism itself we are having a separate block and all. So the system becomes complex and becomes costlier. And it required more maintenance because we are having several sections in the closed loop system. So it needs more maintenance compared to the open loop system because there is only two section, controller and plant, but here we are having a feedback element also. So here the overall gain is reduced, maybe reduced due to the presence of feedback signal. So the gain of the system is dependent on the input and output of the system may be reduced due to the presence of feedback signal in a closed loop system. Here maintaining a stability will be a tedious task because more care should be made to the closed loop system since it contains more number of sections in the closed loop system. These are the disadvantages of closed loop system. Next we can conclude with the difference between open loop system and closed loop system. So if you can say we have already seen all the differences. I am putting it in a table here. So this open loop system is simple and economical, and here this closed loop system is complex and costlier, because open loop system has fewer number of sessions and it is cost effective to build fewer number of sessions, and this closed loop system is complex since it contains multiple sections, and it is costlier also. This open loop system consumes less power. It has only fewer number of sessions, so obviously it will consume less power. Closed loop system has more number of sections, so it will consume more power. Then next, this open loop system is easier to construct because it has fewer number of sessions. Closed loop system is not easy to construct because the system itself is complex with this feedback and all. But this open loop system is inaccurate. Due to the absence of feedback signal, the open loop system is inaccurate and it is also reliable. This closed loop system is accurate and more reliable due to the presence of this feedback signal. So maintaining the stability in open loop system is somewhat easier and the system is stable. But in closed loop system, more care is needed to design a stable closed loop system because the system is already a complex one. So stability includes more complexity to the closed loop system. The final difference is the feedback element is absent in open loop system and the feedback element is present in closed loop system. So these are the difference between open loop system and closed loop system. Okay. So today what are the topics we have seen? We have seen what do you mean by system, and what do you mean by a control system, and we have seen a difference between system and control system with an example. That's with the example of fan we have seen. This fan can't be a system if it doesn't have a blade. It can be a system if it has blades but no regulator. A fan can be a control system if it has a blade and also regulator. And then we saw about the classification of open loop and closed loop system. We have seen the definition for open loop system, its block diagram and its example, its advantages and disadvantages. And for control system, closed loop control system also, we have seen the definition, block diagram, the examples, some advantages, disadvantages, and finally we have concluded it with the difference between open loop and closed loop control system. Okay, thank you.